Welcome to the next video in the series about the Technoprogressive Roadmap, published by the UK's Transhumanist Party. This roadmap features 15 goals for the UK to accomplish by 2035. This particular video covers the second of the group of 3 goals about environmental flourishing. It's goal 10 in the overall set. The UK will be zero waste and will have no adverse impact on the environment. As human activity becomes more intense and more widespread, it often has unexpected adverse impacts on our environment. Goal 9 covered the particular case of potential runaway global warming resulting from increased greenhouse gas emissions. Another example is that widespread pollution from plastics currently threatens numerous ecosystems around the world. Yet another example is the way that fracking for oil and gas increases the risk and magnitude of earthquakes. Indeed, a number of so-called planetary boundaries are approaching dangerous tipping points. The ways in which we use resources from the environment need to be altered onto a demonstrably sustainable basis. Present-day flourishing cannot be at the expense of requiring a reduction in future flourishing. Otherwise, all bets are off regarding achievement of any of the other goals in this Technoprogressive Roadmap. However, by applying innovations in recycling, manufacturing, and waste management, the UK can become zero waste by 2035. As other countries around the world follow suit, the various dangers of environmental collapse can be avoided. Importantly, this can be achieved without requiring humans to adopt a diminished, restricted lifestyle. With a suitable framework in place, we can live in a world with a sustainable superabundance of material goods, healthy nutrition, frequent travel, high-quality accommodation, and so on. Researchers from the Stockholm Resilience Centre, supported by partners around the world, have identified 9 planetary boundaries where human activity is at risk of pushing the environment into potentially very dangerous states of affairs. Climate change, loss of biosphere integrity, that is, biodiversity loss and species extinctions, stratospheric ozone depletion, ocean acidification, biogeochemical cycles, such as flows of nitrogen and phosphorus to the biosphere and oceans, land system change, such as deforestation, freshwater consumption, atmospheric aerosol loading, that is, microscopic particles in the atmosphere that affect climate and living organisms, and introduction of novel entities, such as organic pollutants, radioactive materials, nanomaterials, and microplastics. As the researchers say, crossing a boundary increases the risk that human activities could inadvertently drive the Earth system into a much less hospitable state, damaging efforts to reduce poverty and leading to a deterioration of human well-being in many parts of the world, including wealthy countries. The latest data indicates that 4 of the 9 boundaries may have already been crossed: climate change, loss of biosphere integrity, land system change, and altered biogeochemical cycles. Whilst good solutions are at hand for each of the 9 risks, we need to be aware of 2 important complications. The first complication is that there may be unforeseen drawbacks from various technological interventions that are proposed as solutions to the threats of environmental collapse or resource shortage. In other words, the solutions may turn out to be worse than the problems they are trying to solve. For example, there are reasons to fear potential unwelcome sweeping side effects from agriculture or any other industry becoming overly dependent on new chemical treatments or new genetic manipulations. Larger and more mechanized doesn't necessarily mean more resilient. Biochemical or geoengineering innovations could have escalating adverse real-world consequences that weren't evident from short-term trials or localized pilots. The real world is a much messier, more complex place than any carefully controlled research laboratory. This risk of unexpected escalating side effects requires a total of 4 responses as part of a proactive technoprogressive oversight system. Proposed interventions must be widely discussed and analysed in advance, drawing upon insights from multiple disciplines and diverse perspectives. Once interventions have been approved and applied, careful monitoring needs to take place, checking for any behaviours that differ from what was expected. If any problems do come to light, swift reversals or other modifications will be required. Hence the importance of governance that is both lean and agile. Finally, a spirit of openness and transparency is vital, valuing data over ideology, transcending tribal instincts, and avoiding any temptations to ignore or obscure potential problems. This brings us to the second complication, the various pressures which elevate short-term group-specific perspectives over the full picture. Consider the two-edged role that can be played by powerful corporations. Pursuit of profits often results in innovations that are profoundly useful. But just because a product makes good short-term financial sense for a company and its investors, that's no guarantee of a positive long-term effect on human well-being. For example, there are reasons to fear that the pursuit of profits by powerful agrochemical corporations could result not in the feeding of the world, as promised by these corporations, but in a kind of unintentional poisoning of the world. Various industries have, alas, a long track record of seeking to cover up the risks associated with their products. In summary, potential innovative solutions to environmental collapse or resource shortage face the complication of multiple interactions, system issues, and unforeseen side effects, and also the complication of short-termism, blind group loyalty, and ideology trumping data. These complications can be countered by proactive technoprogressive oversight with its ongoing systems analysis, trustable monitoring, as already described for goals 6 and 7, governance that is lean and agile, and constraints on powerful subgroups. A key role will also be played by the technoprogressive vision of an abundance in which all subgroups can flourish, an abundance with plenty for everyone. Despite the complications described, there are positive routes ahead for each of the 9 planetary boundaries identified, as well as for other possible impending environmental crises. The same themes emerge in each case. Methods are known, in outline at least, that would replace present unsustainable practices with sustainable ones. By following these methods, life would be plentiful for all, without detracting in any way from the potential for ongoing flourishing in the longer term. However, the transition from unsustainable to sustainable practices requires overcoming very significant inertia in existing systems. In some cases, What's also required is vigorous research and development to turn ideas for new solutions into practical realities. Unfortunately, in the absence of short-term business cases, this research and development often fails to receive the investment it requires. For each planetary boundary, the answers also follow the same pattern. Society as a whole needs to prioritize research and development of various potential solutions. Society as a whole needs to agree on penalties and taxes that should be applied to increasingly discourage unsustainable practices. And society as a whole needs to provide a social safety net to assist the people whose livelihoods are negatively impacted by these changes. Left to its own devices, the free market is unlikely to reach the same conclusions. Instead, because it fails to assign proper values to various externalities, the market will produce harmful results. Accordingly, these are cases when society as a whole needs to constrain and steer the operation of the free market. In other words, democratic politics needs to assert itself. In more detail, we can point to 6 answers for how society can address scarcity of goods without adversely impacting the environment. First, improvements in recycling processes, including greater use of nanotechnology, will be able to extract scarce materials from older products, enabling higher amounts of reuse in newer products. Second, alternative designs can be devised, often taking advantage of insights from artificial intelligence, that allow readily available materials to be used in place of rarer ones. In many cases, innovative new nanomaterials could serve as better alternatives to the components presently used. Third, as a consequence of better design and better manufacturing, material goods will become more robust, with self-cleaning and self-healing properties. This will extend their lifetimes and reduce the need for rapid turnover of new products. Fourth, the Asteroid Belt, which mainly lies between the orbits of Mars and Jupiter, is thought to hold huge quantities of all sorts of elements. It will require a major project to mine these asteroids and transfer minerals back to the Earth. However, by taking advantage of abundant solar energy, and with both spacecraft and mining equipment operated via automation, this project could make good economic sense. Fifth, where there is a genuine scarcity, items should be shared rather than being restricted to just a few owners. Accordingly, we should welcome the growth of the circular economy and the associated changes in public mindset. Sixth, the relative importance of material goods will in any case decline, as people come to value experiences more than possessions, and to spend greater amounts of their time in inner virtual worlds. It remains to be seen which of these 6 answers will turn out to be the more important in practice. What is clear is that there are many options to be explored. This exploration urgently needs higher priority and more focus. To accelerate progress, 2 interim targets for 2025 are proposed. The first target is identical to the first target for the previous goal, Goal 9, namely agreement on a replacement for the GDP index as the guiding light for evaluating the success of the economy, where the replacement for the GDP fully incorporates all externalities, especially impacts on the environment. The second target, again, is essentially the same as the second target for Goal 9. It is to establish a reliable, respected source of information about the true environmental benefits and risks of different types of human actions. Existing highly contentious arguments about science and about environmental interactions should have the raw emotion and panic removed from them, so we can all see more clearly what are the real risks and real opportunities. See other videos in this series for more information about the Technoprogressive Roadmap, published by the UK's Transhumanist Party.